This meeting is being recorded.
In this next video from Chapter 19 on electrochemistry, we're going to take a look at sample exercise 2. And in this example, we are asked to complete and then balance this equation using the half reaction method. So if you recall from the last video, you can assign the oxidation states to determine which is being oxidized, which species is being reduced. We can do that quickly here. So chloride is easily the -1. Over here, it goes to 0. So chlorine, we know, is going to be the oxidation reaction. And then our species with chromium, that's going to be reduced. All right, so we don't even have to figure out the chromium because this would be a complicated, algebra to solve for that. But we know it's +3 easily over here. But since we're confirming the chloride is being, or the chlorine's being oxidized, we know by default the chromium is being reduced. All right, so let's take a look here. Let's break these reactions into the two half reactions first. So I know that I'm going to need Cr2O7, and that will give me Cr3+. And then over here, my chlorine, Cl negative, that will have to give me my Cl2. Again, I just separate their half reactions based on the other elements besides oxygen and hydrogen, if they were present, and that's how I group them together. All right, so step 1 now of the balancing of the half reactions. We're going to balance everything but hydrogen and oxygen. So let's balance the chromium. Let me change my color here so we can see the changes as they happen. How about green? So we're going to see that I have 2 chromium over here. So I need to add a coefficient in front. So now I have 2 and 2. Let's take a look at my chlorine. I have 2 on the product side, so I need a coefficient of 2 over here. All right, now my 2 half equations, everything but oxygen and hydrogen are balanced. Let's balance our oxygen next by adding 1 water molecule as needed, because that adds 1 oxygen atom. So now we're balanced on the chromium half equation because we have added 7 water molecules and we had 7 oxygens on the other side. Let's take a look. The second half reaction, we don't have to worry about that. We also don't have to worry about hydrogen. So that one over here, this oxidation half reaction, this is already balanced until we have to reach a balancing of charge. So let's go back and balance H+. So I've added 14 on this side, so I'll need to add 14H+ on this side. All right, so now that I have balanced everything besides charge, let's go back and look at how we can do that. So on my reactant side here, I have +14 with 14 H+, and then I have -2 here. So net, I have +12 on my reactant side. And then over here, I have 2 times +3, so I have just +6, and then this is, if you recall, 0. So I need to account for a change of 6 electrons, or 6 going down by an oxidation state of 6 overall for chromium. So I'm going to add 6 electrons to this side. So if you recall, we can only subtract, we can't add, so I can't add anything to the product side here. So let's transcribe our half equation so far. We have 14H+. We've added 6 electrons. Then I have Cr2O7, 2 negative. That gives me 2 Cr3+ and 7 H2O. All right, so that's our our half equation for the chromium for the reduction. And then, as mentioned, this is already balanced besides charge, so let's do that. I have -2 over here, I have 0 here, so I have to add 2 electrons to this side. So now my other half equation looks like 2 Cl negative plus Cl2 plus 2 electrons. All right, and we know that we also need to have the same amount of electrons going in as going out. So this side is 6. I can multiply over here by 3. And then I'll get 6 Cl negative plus 3 Cl2 plus 6 electrons. So I'm going to use this new equation here to add to this half equation, and overall we will get 14H plus. I'll cancel out those electrons. Then we'll have plus our next our reactant, Cr2O72 negative. My other reactant from the other half equation, I'm going to have 6Cl negative. That's it, right? And then I have my products. I'm going to have 3Cl2 plus 2 Cr3 plus 7H2O. And we'll double check and make sure that we don't have any H plus or water, both on each side. We do not, so we could say that this is going to be our, at the bottom here, our overall balanced chemical equation in acidic conditions.